Hi, this is Andrea Kane, and I'm here with you for HIT 352, which is all about health information systems. We are now on week 3, which means chapter 3 for us, which is Introduction to Databases and Data Analytics. So let's see what we need to learn this week. We're going to assist in the development of a database, compare and contrast the different types of data analytics and their roles in the analysis and improvement of health delivery and services. We're going to develop and manage the data dictionary, develop queries to retrieve data contained in the database, read and understand an entity relationship diagram, identify the primary key contained in an entity, differentiate between a data repository and a data warehouse, expound on the ways that data mining can be useful, complete simple normalization of data, and differentiate between the various types of data, explaining the importance of data standards and how they are established. So let's move on here. Data analytics is the science of examining raw data with the purpose of drawing conclusions about that information. It includes data mining, machine learning, development of models, and statistical measurements. Data analytics. So let's talk about the different types of data analytics. There's descriptive analytics, which use a group of statistical techniques to describe data such as means, frequency distributions, and is used to describe the characteristics of a specific group or population. Diagnostic analytics, which helps a healthcare organization determine why something happened. Predictive analytics is a process to identify patterns that can be used to predict the odds of a particular outcome based upon observed historical data. And prescriptive analytics uses information generated from descriptive and predictive analytics and modeling to determine a strategy for the best outcome and or to suggest a course of action to solve a problem. So descriptive is exactly what it says. You're describing the characteristics of a specific group or population. Diagnostic is is like a diagnosis. Why did it happen? How did this happen? Predictive is, are there any patterns based upon observed historical data? And can you use those predictive analytics, once you find those patterns, to predict a particular outcome? Prescriptive analytics looks at strategies, like a prescription. You're going to try and find the best drug to treat the disease. So prescriptive is you're looking for a strategy for the best outcome or course of action to solve the problem. It's different than predictive because predictive looks at that observed historical data and then predicts odds of the particular outcome that you're looking at. So that's a way to look at those four. Database. A database is an organized collection of logically related data, text, references, or pictures in a standardized format, typically stored in a computer system for multiple applications. So what's the point of having a database and using it? Well, it facilitates data sharing, it streamlines workflow, it assists in clinical decision making, and it provides information for managerial decision making as well as providing data for data analysis. It gives you one place to go to find all sorts of information and then start looking at trends and making decisions and predictions and that sort of thing. A database administrator is the individual responsible for the technical aspects of databases, responsible for designing the database as well as managing the database after its implementation. A data steward or data stewardship is the formalization of accountability and a continuum of stewardship responsibilities across the data's life cycle and across the enterprise. So someone who's a data steward is responsible for making sure that the data's life cycle and how it's used and that it's used wisely and carefully and all of that, that's what they do. Health data stewardship is the management and responsibilities of an activity according to its established goals and objectives, regulatory and accreditation conditions, and other organizational obligations to guarantee, that health information is used appropriately. So there are some certifications. One that AHIMA offers is the Certified Health Data Analyst, or CHDA, and you can go to AHIMA's website and learn more about that there. The triple aim. This concept was developed by the Institute for Healthcare Improvement, or IHI. Its three aspects are to improve the patient experience of care, improve the health of the population, and reduce the per capita cost of healthcare. And they use databases for a lot of that, to collect the information and be able to identify trends and make recommendations and things like that. When you establish a database, you need to make sure it's going to meet the needs of the healthcare organization. And part of the way that you do that is through the data set. This is a list of recommended data elements with uniform definitions that are relevant for a particular use. So some examples of data sets include the Uniform Hospital Discharge Data Set, the UHDDS, and that's a federal data set that's required for hospitals to use. There are more, and we will get into those. Some of those are in your book, but we will definitely be covering those in this class. Data scrubbing or cleansing involves the detection, removal, and correction of incomplete, incorrect, or poorly formatted data in health information technology systems. Detection and elimination of duplicate or redundant information, mistakes made during data entry, invalid values, or non-populated values are included in this. And you look for all of those in each information system. So a database management system manipulates and controls the data stored within the database to meet the needs of the user. Parts of database management systems include data definition language, data manipulation language, data control language, and data dictionary. And you can find all of these in your book in this chapter. Natural language queries use common words to tell the database which data are needed. Query by example is a query method where the user only has to point and click to choose tables and fields contained in the database. And within those, there's a Boolean search, wildcard search, and structured query language, or SQL. And your book does a great job of going through all of these, so I'm going to refer you back to that. Okay, so next slide. SQL, also known as Squirrel, at least to some of us. It's really more SQL, but we used to joke it was Squirrel because it's letters. It's standard language for the relational database. SQL defines data elements, manipulates data, and controls access. The data definition components of SQL allow the user to create tables, delete tables, and show how something is viewed. A data dictionary is a descriptive list of the names, definitions, and attributes of data elements to be collected in an information system or database whose purpose it is to standardize, that's the key area there, definitions and ensure consistent use. A data dictionary assists in improving data quality, data integrity, documentation, data analysis, and data reuse. Within a data dictionary, you're collecting metadata, and there's three types of metadata: descriptive, structural, and administrative. And again, I'm going to refer you back to your book for those. There's also such a thing as a mask, and your book will explain that better than I possibly could. All right, so data content standards. These are clear guidelines for acceptable values for specified data fields. They make it possible to exchange health information using electronic networks, and they identify the structure and content of data elements to be collected by the EHR. Vocabulary is a list or collection of clinical words or phrases with their meanings. They address the problem of multiple ways to define, classify, and represent language. A good example of a vocabulary is SNOMED CT. And your book will talk about SNOMED CT, and we will a couple more times this semester in this class. But feel free to look up SNOMED CT and learn more about it. Data modeling is the process of determining the user's information needs and identifying relationships among the data. There are three different types of data models we'll talk about: conceptual, physical, and logical. Conceptual, physical, and logical. So make sure you read through your book to look at those. An entity relationship diagram is a common type of data modeling that focuses on relationships between entities. An entity is a person, location, thing, or concept. An attribute is facts or data about that entity. Relationships can be one-to-one, where the patient has one attending physician, one-to-many, patient may have multiple lab tests, or many-to-many, where the lab test may be performed on multiple patients. So this is an example of how it looks. This is an example of a one-to-one relationship where the patient has one attending physician. When you're looking at flew right past that. Many-to-many relationships, you have patient has consulting physicians, more than one. There's computer-aided software engineering that's designed to create many of the diagrams and other tools used in the data model. The data flow diagram is a diagram that shows how data moves, input, storage, and output within the system. It's a way to show management and other non-technical users the system's design. Use case is a technique that is used to develop scenarios based on how users will use the data and functionality to assist in developing information systems that support the information requirements. So let's talk about some common database models, looking at relational database models. They include a table and types of fields. These types of fields include alphabetic, numeric, alphanumeric, time and date, and auto numbering. The relational database also includes normalization, query, and key field. And when you're talking about key field, it can be primary key or foreign key. And your book does a really good job of covering all of these and explaining those. So I know I keep saying refer back to your book, but really your book has such great information in it. A hierarchical database model has nodes and pointers. It looks like an organizational chart. It also sets up parent-child relationships. And that's exactly what it sounds like. A parent can have more than one child, but a child can only have one parent in this relationship. Network database model has owners and members, and again, pointers. With common data models, there's object-oriented database models. This includes text, images, audio, video, and other objects, often using Java as a platform. But it's exactly what it says, object-oriented. So you're going to have all these different types of objects. And then you'll have multidimensional database models, and those are data warehouses where there's all sorts of multiple databases being dumped in together. And that's known as a data warehouse. A data repository is an open structured database in which data from multiple information systems are stored so that an integrated multidisciplinary view of the data can be achieved in a single source. It contains clinical, administrative, and financial data. And you can also have a specifically clinical data repository. A data warehouse is a database that makes it possible to access data from multiple databases and combine the results into a single query and reporting interface. A data mart is a subset of the data warehouse designed for a single purpose or specialized use, which makes sense. So you've got the warehouse, and within the warehouse you may have individual data marts that are for a specific purpose or specialized use. Data mining is the process of extracting and analyzing large volumes of data from a database for the purpose of identifying hidden and sometimes subtle relationships that would be unnoticed without the analysis. Data mining techniques include anomaly detection, association rule learning, cluster analysis, classification analysis, and regression analysis. Online analytical processing, which is also part of data mining, this is where data access architecture allows the user to retrieve specific information from a large volume of data through methods like drilling down into the data, consolidation, and slicing and dicing. Some examples of what data mining is used for is best practices in patient care, medication adverse effects, potential fraud and abuse violations, patterns of mortality and morbidity, and patterns of denials. And that is it for Chapter 3. I hope you have a wonderful week, and I'll be back next week to talk to you about another chapter. Take care.